This is Craig Migliaccio from acservicetech, and today we're going over a 20-minute segment of our BTrained HVAC training class, so I hope you enjoy it.
So, you have a PCB printed circuit board, so when you see like two boards, you might have a printed circuit board, your main brain, you might even have a third board, which would be like a noise filtering board, but your IPM right here. So a lot of systems nowadays are going to have a printed circuit board, which is the main brain, with an EEPROM chip in the middle, which has programmed algorithms from the factory. And when I say the factory, I'm talking about the circuit board manufacturer and some equipment manufacturers, and not the same ones that program the circuit boards. The circuit board manufacturers don't want to share all the data with the equipment manufacturer, because then it puts them out of a job. And then we're third in line. We're the technicians out in the field trying to fix these things. So you got to think like that. That's a lot, going on. And then we're trying to understand how these systems work. And then they're changing the pumping speed of the compressor and also the hole size in the EEV potentially every 20 seconds to 2 minutes. That's when it's happening. And if you want to put your multimeter on like two of the four wires, like the common wire and one of the four wires on the EEV, the 12-volt pulses that are going to that EEV are happening so fast that you can't even measure it with your multimeter. I'd love to tell you, I'd love to give you better news on that, but I don't have the news for you. So that's why I'm saying, break the systems down so you at least know how to operate them, how they work, and what's going on, so that you know at least what's happening in the systems to diagnose a system that's wrong or bad. Also, a lot of the components in a mini-split, and this is what's happening across the country, is when you have the training centers are now taking mini-splits, and they are just deconstructing them, checking with electrical resistance on all the components, because that's the one thing that's going to remain true. It's very easy to determine if a three-phase wound compressor is intact. As long as it's not mechanically seized, electrically, you're just checking the resistance that's going to match on every single pair, and it should not have any continuity between the three wires and the ground, that it's not shorted. Same thing with the EEV, you can check the electrical resistance. We're going to get into all that stuff. But anyway, printed circuit board is the brain. The outdoor unit is the main brain. You're going to have another indoor unit PCB, which is another brain, but this is the master brain to the whole system. It's communicating with low voltage direct current pulses. This PCB in the outdoor unit is going to allow the single phase electricity over to the intelligent power module, and it's going to communicate with the intelligent power module to tell it what speed to be running the compressor at. And so now on these smaller mini splits, you're going to see an all-in-one board, and you're going to see the little aluminum heat sink in the outdoor unit area. So it's between the fan and the coil, and if you allow that to get too much dust on it, you're not going to have airflow going across the little heat sink, the aluminum heat sink. The circuit board is going to fail just due to a preventative maintenance problem. So now, manufacturers are now, instead of having this, now a lot of them, or they're starting to think about it, at least the high-end ones or whatever, what they're doing is they're starting to go and on like medium-sized systems, they can't do it on the smallest ones, it doesn't make any sense. But on the medium-sized units, what they're doing is they're making a refrigerant heat exchanger, so they're hooking the line, like the low-pressure line that's going into the accumulator, they're hooking that and putting a block heat sink and touching the tube onto that, so you're absorbing the heat from the IPM module right into the refrigerant. Because then, if somebody forgets to do the maintenance on their system, it's not going to destroy the circuit board and give the equipment manufacturer a bad name. Crazy. You may have noticed in the last 4 years, they're doing, 3 years I would say, they're becoming more serviceable. Like at the indoor wall-mounted units, you can finally get to the circuit boards now, whereas before they were buried. They're starting to make it a little bit more serviceable, because we're, in the United States, we go and pay for something. We charge a lot for the labor to install these things. And so the customer has a high price tag for when you have an installation on a system. And it's not as easy as just throw it away like it used to be with these mini splits. And so they are slowly changing the designs to make them more serviceable. They're trying to improve the designs to decrease the failure rate. And by the way, you better be putting surge protection on these systems. One of the largest causes of failure on a mini split is when the circuit board fails. And it makes us look bad, like the contractor. Like, you pour your heart and soul into a job, and then all of a sudden, like a month later, the circuit board fails. the customer says, you must have put a crap system in, and they blame you because they just gave you the check. But the thing is, if you would have put surge protection in, it would have allowed if there's a lightning strike down the road or a grid problem that you have no control over, or a problem at the power pole, or maybe at the lugs behind the globe at the building, maybe there's electrical resistance there, you have some type of electrical problem, either low voltage or high voltage or something, at least a surge protection is going to allow, like if you have extremely high voltage, it's going to allow it to temporarily short to the ground to dissipate it instead of going into the outdoor unit. We have a trade-off now also with the over voltage and under voltage protection. Everybody's getting in the game now. All the not the equipment manufacturers, the third-party aftermarket manufacturers are getting into the game of putting surge protection and voltage monitoring like that's something that you can hook between the electrical disconnect and the outdoor unit. And some have it all as one box. So you can buy it all as one. And so if it's like 240 volts normally and it goes up to like 260, it's going to cut the power off to the outdoor unit to save that circuit board. And then likewise, if it goes down to like 208 or something, 208 volts or something like that, it's going to cut off power to the outdoor unit so that, once again, it doesn't get damaged at the outdoor circuit board. Well, here's the other problem. If you're going to go service a mini split, what I'm going to tell you you should do is you should be putting it into standby mode, say at the remote or whatever, put it into standby mode and listen and wait for the compressor to stop. That's when you pull the electrical disconnect. If you're pulling the electrical disconnect while the compressor is running, the shock is happening in here in the IPM. You could literally be causing damage to the system at the IPM module by pulling the disconnect while the thing is running. And I know that sounds funny, but that actually is happening. People are having boards fail just due to pulling the disconnect. It even happens on ECM like indoor motors, like on like air handlers and furnaces now. The shock is being absorbed in the circuit board that's powering the compressor or the fan motor. So that's what I'm going to tell you to do. Put it in standby mode, wait for the compressor to stop, then pull the electrical disconnect in order to service it. As well, if you're trying to check electrical resistance values, say like on the back of a IPM or something like that, you want to wait 5 minutes, allow the capacitors to discharge by themselves. They'll automatically discharge, but you have to give them a little bit of time. Anyway, crazy, right? Yes?
So what's probably the difference between you pulling the disconnect?
I know. Yeah, thank you. I appreciate you saying that because that's where I was trying to get at and I lost it. Okay, so what's worse? What's worse, going down to 190 volts or cutting it off? You're absolutely right, it's a trade-off. So the voltage monitoring and protection is going to cut off power to the unit while the compressor is running. But the thought is that the failure rate going into the circuit board will be less than if the voltage went down to like 180 volts or some crazy weird thing, or up to 300 volts or whatever it may be. It's protecting the IPM, but you just hit the nail on the head, because if you set those wrong, the overvoltage and undervoltage protection, it's going to be doing it constantly. Wham, 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 turning it off constantly. Well, guess what's going to happen? You now broke your system again because you put the protection device in. It is a trade-off, and I don't have the best answer for you. I've talked with manufacturers on this, the equipment manufacturers. We've gone back and forth with it, and it's like they're like, ooh, we don't want to really give guidance on that because it could damage it either way. So the consensus is, at the very least, you must put surge protection in. You can put voltage monitoring in there, but if you have voltage that's like constantly varying due to the grid changing and stuff like that, it could be doing the exact same thing and turning the power off, causing a failure that way. Crazy. I don't have an answer for you. I'm telling you what the situation is. A lot of this stuff, I wish I had answers for you. I'm just going to be telling you where we're at. And because you also have to think, like, we're all learning, we're all like experimenting, we're all trying to like test things, try to figure things out, try to figure out what the best thing is, because we put our heart and soul into this stuff. You know what I'm saying? Like, we take pride in what we're doing, and it hurts when you have systems fail and the customer looks at you like you did the job wrong. No. Like, it was a refrigerant leak from the manufacturer because they chose the wrong manufacturing plant, and then they have too thin copper. It's like, that's not my fault, but the problem is you have to be able to build your pricing up to a certain amount in order to make sure that you can absorb the shocks of the things that you need to keep your word on. So like learning about how to run a business financially properly, you might want to go and talk back there in the back and try to figure out, your better pricing. Try to get some guidance on that so you can build that into your prices so that you can do the right thing. The worst thing in the world that would be if you charge not enough for the job, but you take great pride in it, but then you're constantly kicking yourself having to go back and warranty things, but you haven't taken enough income in to begin with, and you're like just running yourself into a hole and you're not making any money, which then therefore you're not supporting your family well. It's like this rough thing. It's a tight thing. You have to get to a point where you feel comfortable and you're making the correct amount of money for all this on-night call stuff and everything. Likewise, no amount of money in the world is going to be like good enough for the time away from the family. You know what I'm saying? I had dreams about this stuff, like at my son's baseball game. I had dreams about this since I was 18. I'm not going to get a phone call at my son's baseball game and say, I have to go, and while he's playing, I just disappear. I'm just telling you that's crazy, but I've had that vision in my mind since I was like 18 years old. I'm not going to have that happen. I'm not going to let that happen. I want to find a balance to make sure, that I can take care of people. I can keep their systems running. I can take care of them when it's like 0 degrees outside, but you have to find a balance, and that's what's important, and that's all up to all of us. We have to guard our families. We have to take care of people and guard our families. Yes, sir. They would not warranty the circuit board if it did not have surge protection again. Yes, absolutely. When I say you should put surge protection on, it's mandatory, it is mandatory. But then you're saying, well, why don't they just put that in the outdoor unit? And the reason is because surge protection is not infinite. You have a LED that needs to be exposed to tell you when the surge protector no longer can protect the system and needs to be replaced again. They don't just last forever. It's like the same thing as like if the mini split manufacturers figured out a way to like put a filter dryer in, if they had subcooled liquid like constantly in one spot, which they don't, and they put a filter dryer in there, well, what happens when that filter dryer is clogged? Then it's their fault, right? So they're putting that on because they're saying the surges are not our problem, and so they're saying that's your thing. So you need to do it. So a lot of time, at least in New Jersey and in other locations, we connect the electricity from the disconnect to the outdoor unit. So we could technically put the surge protector on the outdoor disconnect and tie into the load lines, which we're going to see. It's in here, and in order to protect the system. But we're not allowed to touch the line side, at least in New Jersey. Every state's going to be different. So this is being recorded, but every state is different. Yeah. But they also have disconnect boxes that have the surge protection built inside of it. And then they have still the LED light that tells you if it's basically up. The protection device is no longer going to be protecting the system anymore. The problem is, if you're a licensed HVAC contractor, you're technically, a lot of times in many states, you're not allowed to switch out the disconnect. So what are we supposed to do there? But anyway, yes, surge protection, absolutely 100%. You have to build things into the price of the job. Just like you have to build in the price of like changing your vacuum pump oil out and silly things like that, you are going to buy surge protectors in bulk, and you're going to put them in the systems. And guess what? Now we don't have PSC motors anymore. We have ECM motors in even single-speed systems in the air handlers and furnaces and stuff like that, and those are susceptible to lightning strikes and power problems. So now we're putting surge protection on those things as well. There's manufacturers that have like third-party manufacturers, not equipment manufacturers, like Zebra and different ones like that you're like unplug the ECM motor, the ECM 3.0, and you're plugging in the surge protection in between the power harness and the board and stuff like that. But that's only protecting that part. So if you put surge protection over at the inlet of the system on the power lines, then it's going to protect that system. Anyway, we'll get to that on here. All right, so testing compressor resistance at the wiring plug. So you have 2 ohms, 2 ohms, 2 ohms right here. Depends on which, it's all the same basically, but you're checking it in pairs. So the power is off. Okay, so first thing we do, put it in standby mode. Compressor's off, pull the disconnect. Then you are disconnecting the wiring harness from the outdoor circuit board, which will be, in this case, it's the IPM or the combination PCB/ICM, printed circuit board. It's like so dumb that it's a PCB, printed circuit board. Like you just call it a circuit board or call it a board or something, I don't know. PCB. So anyway, combination PCB/IPM or whatever. There's also some manufacturers, equipment manufacturers, have these little indents on the spade terminals, and you have to squeeze the spade terminals with the crimp connectors in order to release the tab, in order to pull the terminal off. Don't just yank on it, you will break the spade terminal right off the circuit board. You have different things like that going on as well, but some of them have just like a little wiring harness that you can just disconnect. That's nice. So you're not going to go straight here, you're going to go to the wiring harness plug and check your electrical resistance. If you get a value that's like incorrect, like maybe it's OL or something like that, means open line, you can like throw somebody off, somebody that you know, like they're like, OL means open line. You're like, yeah, OL, you know, it means over limit, you know, over the limit of the electrical resistance that the multimeter can read. You know, like you mess with them a little bit. But OL just means the probes are not touching, okay? And here's another thing I want to tell you is that, like when you put the probes up in the air on your multimeter, in order to check if your multimeter, the probes are correct, you put them up in the air, they're not touching, it reads OL, open line, they're not touching. When you touch them together, it should read 0.0 ohms of electrical resistance. If you're measuring 1 ohm, half an ohm when you're touching them, either you need to turn the power off to the multimeter, take some steel wool and steel wool the probe tips, then wipe that crap off, turn the multimeter back on, touch the probes. They should be reading 0.0 ohms of electrical resistance. If I see that my probes are not reading that, they're reading more than like 0.1 ohms of electrical resistance, those probes are going in the trash. I'm going to put new probes on. And so because that's going to mess up your electrical resistance readings for everything that you're measuring, everything. And so it's the same thing as calibrating your temperature reading instruments. Those probes can go bad over time, and they will go bad. You know how we like wrap them around the multimeter or whatever, or we're putting them in a little case and stuff like that. Buy an extra set of probes in order to replace them if your electrical resistance value is 1 ohm or something like that when you touch the probes together. Otherwise, when you go to do something like this, your electrical resistance measurements are going to be off. They're not going to be correct. Anyway, so if you read OL at the prior spot, then you're going to go ahead and open up the disconnect, open up the wiring harness area over here in order to then pull your wires off of the spade terminals. By the way, this is the weakest part of the entire system. On single speed systems and on mini splits, this is the area where the electrical wires go into the pressurized cabinet. If you yank on these and twist them and pull, you could have refrigerant blow out in your has anybody ever has that happened to them in this room? 1, 2, 3, come on, be honest. 4, you guys hear that? We have a room of 100 people and 4% have had this happen. Now think about how much time you've had in. Think about maybe somebody in the room has 20 years or 30 years or 40 years or whatever. 4%. You're pulling the refrigerant to have refrigerant blow in your eyes or something like that. You want to wear safety glasses. But you're not going to come into this cabinet right here unless you get bad measurements at your wire connectors. Everybody hear that? You don't have to go disconnecting them from here. Plus, once you've pulled them off, they're no longer as tight as they were before, and that could be a weak point of failure because you have a high electrical resistance because now your connections are not as tight. Anyway, so 2 ohms, 2 ohms, all of a sudden we have OL. Well, that means that one of the electrical windings has opened up and you have a problem. And so that means that that compressor is no longer electrically good. Likewise, if you have any type of electrical resistance whatsoever on your multimeter when you measure from one of the tabs or the wires to the ground, either they call it a scratch test or whatever, onto the frame here or just right onto the copper or something like that. If you read any electrical resistance on your multimeter here, you know you have a problem. One of the windings has shorted up against the ground frame of the compressor. That's a problem. So that's how you tell electrically if it's intact. You should be reading OL when you test the ground. You should be getting a matching electrical resistance when you test between all 3 pairs. Then you're moving to the spade terminals. You don't want to loosen the connectors or anything like that down in that area. And plus, some have a seal that once you take it off, you'll never be like watertight again on that. Now, a mini split, the compressor compartment is the electrical compartment. You really don't have any rainwater in it like you would in a single speed system that has that top air discharge where all the rainwater's coming down into the accumulator and the muffler, the filter dryer, the compressor, and everything like that. Like that's when you really got to make sure that cover is sealed on there tight, man. Whew, it takes a little bit of water and you're done. But these are a little bit more shielded in the compartment.
If you want to learn more about inverter mini split systems and the refrigerant related procedures, the electrical procedures, and all the components inside, how the system works, make sure to check out our Inverter Mini Split Operation and Service Procedures book, which is available over at our website at acservicetech.com, over on Amazon, and also on Google Play and Apple Books. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.